Calculating the load for a duplex receptacle involves understanding the National Electrical Code, (NEC) requirements and practical considerations. A duplex receptacle, which is a standard electrical outlet with two plug-in points, is generally calculated at 180 volt-amps per receptacle according to NEC 220.14. Since a duplex receptacle has two outlets, the total volt-amp calculation for one is 2 times 180 volt-amps, which equals 360 volt-amps. Now, to determine how many duplex receptacles can be placed on a 20 amp 120 volt circuit, we need to consider the total capacity of the circuit and the volt-amp load of each receptacle. A 20 amp 120 volt circuit has a total capacity of 2400 volt-amps. This is calculated by multiplying the amperage of the circuit, which is 20 amps, by the voltage of the circuit, which is 120 volts. Therefore, 20 amps times 120 volts equals 2400 volt-amps. To find the theoretical maximum number of duplex receptacles that can be placed on a 20 amp 120 volt circuit, we divide the total volt-amp capacity of the circuit by the volt-amp load of each duplex receptacle. So 2400 volt-amps divided by 360 volt-amps equals approximately 6.67. Since you can't have a fraction of a receptacle, the theoretical maximum is 6 duplex receptacles. However, it's important to note that the NEC allows for circuits to be loaded to 80% of their capacity, especially in continuous use applications. Continuous use is defined as a load that operates for 3 hours or more. Therefore, we need to consider the 80% dirting factor. To calculate the allowable load on a 20 amp circuit with the 80% dirting factor, we multiply the total capacity of 2400 volt-amps by 0.8, which results in 1920 volt-amps. To determine the number of duplex receptacles that can be placed on the circuit with this dirting factor, we divide 1920 volt-amps by 360 volt-amps per duplex receptacle. The result is approximately 5.33. Again, since you can't have a fraction of a receptacle, we round down to 5 duplex receptacles. It is important to also consider the actual loads connected to the duplex receptacles. If each duplex receptacle is used to power equipment that draws additional volt-amps, the number of receptacles that can be supported by the circuit will be reduced. For example, if each duplex receptacle is used to power a computer and monitor with a combined load of 300 volt-amps, the total volt-amp load per duplex receptacle becomes 360 volt-amps plus 300 volt-amps, which equals 660 volt-amps. In this case, to determine how many duplex receptacles the 20 amp 120 volt circuit can support, we would divide the allowable load in the circuit, considering the 80% dirting factor, which is 1920 volt-amps, by the actual volt-amp load per duplex receptacle, which is 660 volt-amps. So, 1920 volt-amps divided by 660 volt-amps equals approximately 2.91. Therefore, in this scenario, only 2 duplex receptacles should be placed on the circuit. When planning electrical circuits, it's important to adhere to the NEC guidelines and to consider the specific load requirements of the equipment that will be connected to the receptacles. Overloading a circuit can lead to overheating, trip circuit breakers, and potentially electrical fires. The NEC provides tables and guidelines for calculating loads and determining the appropriate circuit sizes for different types of occupances and applications. In non-dwelling units, NEC 220.14a states that each receptacle outlet shall be calculated at not less than 180 volt-amps. For dwelling units, the rule is different. Small appliance circuits and laundry circuits are calculated differently. In dwelling units, small appliance branch circuits are required to be rated at 1500 volt-amps per circuit. These circuits are typically 20 amp circuits and serve kitchen and dining areas. Laundry circuits are also required to be rated at 1500 volt-amps per circuit. These are also typically 20 amp circuits and serve laundry areas. These requirements ensure that there is sufficient capacity for the appliances typically used in these areas. It is very important to accurately calculate the load on a circuit to ensure that it is not overloaded and that it can safely supply the power needed. Overloading a circuit can lead to serious consequences, including fire. Always consult with a qualified electrician to ensure that electrical work is done safely and in accordance with the NEC. When calculating loads, it is always a good idea to add a safety margin to account for future needs or unexpected loads. This can help to prevent overloads and ensure that the electrical system is able to handle the demands placed on it. Also, consider the type of occupancy when calculating loads. Different types of occupancies have different load requirements. For example, a commercial building will typically have different load requirements than a residential building. In summary, calculating duplex receptacle load on a 20 amp 120 volt circuit requires understanding the volt amp load of each receptacle, the total capacity of the circuit, and the impact of actual load. Always adhere to the NEC guidelines, consider safety factors, and consult with a qualified electrician to ensure safe and proper electrical installations. Remember to account for continuous loads by applying the 80% earthing factor. This ensures that the circuit is not overloaded and that it can safely supply the power needed. By following these steps, you can accurately calculate the number of duplex receptacles that can be placed on a 20 amp 120 volt circuit and ensure the safety and reliability of the electrical system. Finally, always prioritize safety. Electricity can be dangerous, and it's crucial to take all necessary precautions to prevent accidents. If you're not comfortable working with electricity, it's always best to hire a qualified electrician. Remember that while theoretical calculations provide a baseline, real-world applications often necessitate adjustments based on specific usage patterns and connected devices. Always prioritize safety and consult the latest edition of the NEC for the most accurate and up-to-date information. In addition to the NEC, local codes and regulations may also apply. These local codes may have more stringent requirements than the NEC, so it is important to be aware of them. Before starting any electrical work, it is always a good idea to check with the local building department to see what codes and regulations apply. Also, it is important to use only approved electrical materials. Approved electrical materials are those that have been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, or all. Using approved electrical materials helps to ensure that the electrical system is safe and reliable. When installing electrical wiring, it is important to follow all applicable codes and regulations. This includes using the correct wire size, properly grounding the system, and protecting the wiring from damage. Improperly installed electrical wiring can be a fire hazard. Also, it is important to properly label all electrical circuits. This makes it easier to identify the correct circuit when troubleshooting problems or making repairs. Labeling circuits also helps to prevent accidental shocks. When working on electrical circuits, it is important to always turn off the power at the circuit breaker or fuse box. This will help to prevent electric shock. Before turning the power back on, it is important to double-check all wiring connections to make sure they are secure. Loose wiring connections can cause arcing, which can start a fire. Also, it is important to use caution when working around water. Water conducts electricity, so it is important to avoid contact with water when working on electrical circuits. Finally, it is important to have a fire extinguisher nearby when working on electrical circuits. In case of a fire extinguisher can help to put it out quickly and prevent it from spreading. Remember, safety is always the top priority when working with electricity. By following these safety tips, you can help to prevent accidents and ensure that your electrical work is done safely and properly. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. They can provide you with the information and guidance you need to work safely with electricity. In addition to the above, consider these points. Firstly, future expansion. Plan for future electrical needs. If you anticipate adding more equipment or appliances in the future, consider increasing the circuit capacity to accommodate these future loads. Secondly, dedicated circuits. For high-power devices, such as space heaters or large appliances, consider using dedicated circuits. Dedicated circuits prevent overloading and ensure that these devices have a reliable power supply. Thirdly, load diversity. In some cases, you may be able to take advantage of load diversity. Load diversity refers to the fact that not all electrical devices will be operating at their maximum load at the same time. If you know that some devices will only be used intermittently, you may be able to reduce the overall load calculation for the circuit. Fourthly, voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. When planning electrical circuits, it is important to calculate the voltage drop to ensure that it is within acceptable limits. Fifthly, grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electric shock. Bonding connects all metal parts of the electrical system together, which helps to equalize the voltage and reduce the risk of electric shock. Sixthly, surge protection. Surge protection devices, or SPDs, protect electrical equipment from voltage surges which can damage or destroy electronic components. SPD should be installed at the service entrance and at individual circuits to provide comprehensive surge protection. Seventhly, arc fault circuit interrupters, or ASIs. ASIs are circuit breakers that are designed to detect arc faults, which are a common cause of electrical fires. ASIs should be installed in all branch circuits that serve dwelling units. Eighthly, ground fault circuit interrupters, or GFCIs. GFCIs are circuit breakers that are designed to detect ground faults, which can cause electric shock. GFCIs should be installed in all wet locations such as bathrooms, kitchens, and outdoor areas. Ninthly, regular inspections. It is important to have your electrical system inspected regularly by a qualified electrician. Regular inspections can help to identify potential problems before they become serious. Tenthly, maintenance. Proper maintenance is essential for keeping your electrical system safe and reliable. This includes cleaning electrical panels, tightening connections, and replacing worn or damaged components. By following these guidelines, you can ensure that your electrical system is safe, reliable, and able to meet your needs.